The last part of 10.1 is a practical problem. And if you want to look along in your textbook, it is example 6. Here we're talking about a solar trough. Solar trough is a reflective parabolic surface. And as you go on in physics, you'll learn a whole lot more about parabolas and what happens. But essentially, they are used to reflect the sun's rays from the surface towards a central pipe that carries water and heats it. And that water produces steam that then produces electricity. And you can see the picture of what that looks like. We're just going to create just the curve of that right here. On our coordinate system. And on the y-axis, I want to go up 3. On the x-axis, I want to go right all the way 5 units at least. So 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. I'm just going to stick a -1 there just to show, but really, truly, this is a positive function. And the parabola, just to place it properly, you'll notice that it has a vertex at 0, 0, and that it's going to be hitting right around -5 here. It's going to be about 2 1/4 up here and +5 up here, 2 1/4 up here. So you're going to want to draw your curve this way. And actually, I'm just going to end it here. This is not an arrow. This is actually, it's a curve which ends. So just to demonstrate that, I'm just going to kind of show what this solar trough looks like underneath, right? And this is so that the rays essentially reflect this way. The sun's rays reflect here and towards the center, and from here towards the center. You'll later learn that there's something called a focus in a parabola, but that's really an algebra 2 or physics concept. So here they have given us the equation for this parabola or this function, and the equation for that is y equals 0.09x squared. And this is what models the cross-section of the reflective surface. And our measurement, by the way, is in meters. So this problem is asking us simply to find the domain and the range. Now, this is something we haven't looked at in a bit. If you remember, the domain just means x values. What are all the possible x values? Well, what is the domain? Where do you see the x values look like they start at -5 and they go all the way to +5. So my x values are going to go between, they're going to be greater than or equal to -5 and less than or equal to +5. And it's greater than or equal to or less than or equal to because it also includes 5. Our range is all the y values. Now, if we've established our domain, finding the range is pretty easy because as long as we have an x value, all that we do, and we've been doing this all along with linear equations, exponential equations, is we just plug in our x value here. So if my smallest value is a -5, I'm going to plug that in right here. Y equals 0.09 times -5 squared, right? And I end up with y equals 2.25. And that makes sense because that's about what I drew, right? 2.25. But it's only from 0 to 2.25, right? There are no negative values. So when I draw my range, I say y, it's definitely greater than or equal to 0. It can be 0, but it's less than or equal to 2.25. And again, a reminder, these are in meters. So this gives you some idea of one of the uses for a parabolic function or quadratic function. There are many, and we're going to explore them a lot more as we go into 10.2 and beyond.